Hello and welcome to this screencast of Kubefront. I'm known as rctl and I'm the creator of Kubefront. Kubefront is a project to enable simple Kubernetes cluster management from your browser. It is similar to the official Kubernetes dashboard, only a bit simpler. It is meant to be used for a quick and simple overview of your cluster's overall health and to allow simple management of running deployments in the cluster. We will start by turning on the backend for Kubefront. It can be done inside the cluster or from any machine with sufficient kube control access. Once the backend is on, we can note down the generated admin password in our clipboard. This password will only be generated if Kubefront has not been run before. We can then fire up the frontend and head over to it in our browser. We can sign in with user admin and the password that was generated earlier. We can now see the basic dashboard for Kubefront. Nice features of this dashboard is that we can customize the way it looks by dragging or resizing different cards. This is persistent between page refreshes, so your dashboard will always stay the same. All of the data featured across Kubefront is live from the Kubernetes cluster. We can see this by hovering over any information icon on a collection to see when it was last updated. Whenever something changes in Kubernetes, the data on the dashboard will be automatically updated. That is what the WebSockets is used for. We can also look at data in different categories throughout the menu. Kubefront features a pub sub feature, so it only subscribes to updates about data which is present on the screen. So when we are in the node section, only data about nodes will be streamed from the backend, creating efficient data flows and using minimal amount of bandwidth while still featuring fully live data. Remember, changes are streamed, so we never refresh the whole collection of data while on a single page. If we head over to the pods, we can see the different pods that are running in the cluster. We can use the context menu to perform different actions on it, such as deleting. Here, Kubefront uses something called Kubefront workers to conduct work on objects in Kubernetes. Because workers are being used, we can protect ourselves from concurrency issues. Whenever there's a job running on our resource, other users will be blocked by the loading indicator from starting new jobs onto it. Because of this, we can minimize the likelihood of a collision between user sessions. This status also persists between page refreshes and different sessions. From the deployments, the same logic applies. Kubefront reuses many components. Here we can see that the pod components is being reused for displaying a deployment's corresponding pods. We can also delete deployments from here. The service section is similar. It displays all cluster services and to where they send their traffic. It also shows the cluster IP which is allocated to that specific service. This concludes the functionality of Kubefront. The codebase is built to be easy to expand to more features in Kubernetes and to adapt to dynamic tasks performed in the dashboard. These examples show potential behind Kubefront and explains how using pub/sub solutions and WebSockets can help to create efficient live data flows. You can read more about Kubefront at github.com/rctl/Kubefront. And welcome to the second part of this screencast, which is the bit more informal part. Where I'll be actually going through some code and show you what the system is built with and show you some of the code behind it. So I've fired up the system here, like I showed you in the part 1 of this video. And I'm going to go through some of the different components here and talk about them a little bit and show you what they are actually built up from. So what's the code operating behind all these different solutions? So you're aware of how the system functions in general. You know, we have a WebSocket that has a subscription feature, so it subscribes to data that is updated from the cluster. And it uses both REST and that WebSocket to communicate with the backend. If we open the Chrome DevTools, we head over to the networking. Let's close this section here and make this a bit bigger. go into networking, and then we do a page refresh here. Now we see a bunch of data is being fetched, and what do I fetch from here are the workers and the nodes. So the nodes are the things that you see on the screen, and the workers are the workers that are running current jobs on different parts of the system. There's also an upstream here, which is a WebSocket that I use to communicate. So we check the frame section here. We can actually see the data that's being sent between the server and the client. You can see here that the nodes are actually triggered as a change every 10 seconds, and that you may think, wow, what? Nothing changes on the screen while you have data flowing. And the reason for that is because Kubernetes updates the heartbeats of nodes every 10 seconds. So because the data is naturally changed, it triggers an update and I get the new data. I could choose to use that data on the front end, which I do here with the checkbox that tells me that the node is ready. If that heartbeat is not received within 20 seconds or whatever it's coded for, it's not going to it's going to change to warning indicator instead. This becomes more interesting when we change to the pods. See now what happens. We can see that the client says that it no longer wants to subscribe to nodes because nodes are no longer present on the screen. And it also changed, okay, I'm going to subscribe to pods instead. So now I'm going to get updates about pods. So interesting here is that if we go into a terminal, if we open a new tab in our terminal, and then we use kubectl to do something. Let's delete this pod over here. If we do that, then we can see that, it disappears and something happens, and then we get a whole bunch of updates here. These are the updates that are triggered when I do kubectl and then delete on that pod. Is that it starts a shutdown procedure, so the pod is shut down here, and then there's another ID here, entity ID, which is the new pod that's being generated by the deployment as a replacement for this pod, which is turned off. Same thing happens when I do delete pod here manually. You do notice that this deletion here doesn't delete the pod instantly. The reason because of that is because in this demo version of the platform, I want to be able to actually see the spinner of something happens, which doesn't really happen if you don't have a short delay in the code there, because otherwise the deletion job is so quick you will never see the spinner, and you have no opportunity to test affinity between different sessions and things like that. So here you can see a bunch of data is being streamed about pods, but we don't see any data about nodes because we don't subscribe to that topics. If we jump over to deployments, we start to see that we are now subscribing to deployment pods but not nodes, because in this deployment view we are also using the pods. So we can also see that we are actually also using the pods here as part of the deployments. Another interesting thing to see here is, but probably there aren't much interesting things actually to see here, but if we have a service change, for example, it would also appear as a change here, which is perhaps a slightly bit of an interesting thing. And of course the dashboard sort of subscribes to all the data that is available. This allocatable memory, node count, allocatable CPU, and pod count is actually built from the node collection. So it's not separate data, it's all constructed from the information that is given about the nodes. We can also see the different calls here being sent as a REST requests. Every time we navigate, we actually do request to get the entire collection. The reason for that is because I want the system to work perfectly fine if you do not have any WebSockets. If you disable WebSockets, this would work perfectly fine, but you won't have live data, of course, but you will still be able to navigate and you will still be able to see information on the screen. You would just have to refresh your page to actually get a data refresh if you don't have any WebSockets. And that's why I also have this information indicator here, is that you can see how long ago was things actually updated, which is given you a hint if there's some missing updates or whatever. Okay, so now we've gone a little bit deeper into the system, and now let's start looking at some of the code behind all this. And the frontend is built in Vue, which is a web framework for building front-end applications, and I've been using that quite a bit. And one of the things that I feel that I'm missing from Angular, I'm an Angular guy from earlier, so I've been working a lot with Angular, and in Angular you use services to construct all your different kinds of data, right? You manage your data flows inside of your services. In Vue, well, there's Vuex and there are other things you can do, but for me the switch to Vue wasn't really that natural. So I thought, okay, how do I sort of recreate the services that I have in Angular in Vue? And actually that's quite simple to do. It's just, you know, creating some scaffolding code and setting up some different functions for your data, and you're ready to go. It's basically you have built a replacement for services. So we can see this is a node service, and we can see that we have last updated information. That's what you see when you hover over the information icon. We have a collection of all the nodes, so we know every node that's in the cluster that's stored in our application memory. We have a set of broadcasts that we can call whenever we like. We can see that a node has been updated or added. Refresh here triggers the entire refresh of everything, so we basically just download all the data through the REST API. So this is what is run at first when you refresh your page. And then we can do things like we can collect the count, or we can do a listing of all the items. And then this service also listens to the WebSocket, right? So it listens to the upstream service. So the upstream service can say things like a node has changed, give us the entity ID and the data, and then our job here is to basically update that data, and if that's an ID that is unknown to us, we just add it to the collection, and then we push a broadcast that says, okay, something has been added. You need to re-render your page. We can look at the upstream as well. This is where we have the WebSocket. I did not know how to pass any headers through the WebSocket in JavaScript. So what I did was just to pass the token as an URL component, which is, in my opinion, not very good looking. It's not very good, you know, if it gets stuck in any cache for some reason or whatever. So that's probably something you would like to avoid going forward, to replace this authentication with something else. Maybe send an authentication message here when you have established connection or whatever. But then again, if you want to be slightly bit of stateless, you don't really want to start with some formal authentication. So it's a bit of a pickle there to know which one to go for. I just went to add it into the URL. So this WebSocket, it listens for different broadcasts from the server. It can you can subscribe, unsubscribe to different topics. That's basically telling the server, hey, push me this data, hey, push me that data, or whatever. And then this sort of just on a message just sort of emits that message onto the bus, which is the common communications component in this application. We of course have services for all the different types of collections, so we also have services for pods, for example. When we go to the view, so we look at the app for a second here. It doesn't really contain much information, but here is where we handle the authentication service, where a sign out would be basically re-render the UI as you're signed out. So when you click the sign out button, that's what happens. The bus is basically just an empty Vue instance, so we can talk over that one. The main contains all the services, which are passed in as Vue prototypes, so we can use them in Vue easily and swap them if we need to. The router is not very that interesting, but it's just basically set up all the different routes that are available. If we look at the views, we can look at the dashboard, which has the grid layout. I went a bit lazy and I didn't actually code the grid layout myself. You know, if that was an available node component, I could just use it as is. So I did. Shame on me, maybe, I don't know. So here are the different components that we can use in the different cards. We have a basic layout which tells us, you know, the width, the height, and the XY position of things, and which component to actually render inside of that card, the resizable card. So it's quite easy just to you know, insert whichever component you want here and have it rendered in the card. So you don't have to do much coding when you add new components, which is the basically point of the entire Kubefront, is to be easy to expand. Here's the subscription. So we start by subscribing to all the things we need to subscribe to for this UI to properly work. We refresh the data, so we start with an updated version of the data. And we can also, when we destroy this component, we unsubscribe to this information because it's no longer valid or relevant, so we don't want to have to receive more information about it. When we look at the different subviews, they're basically the same. They have these views here, which are, you know, a scaled down version of the dashboard, which is targeted towards one single component. They are very simple to just subscribe to the information that they need. They refresh, so they start with a refresh set of data, and they have the component inside. These are tagged as extended, so the component can tell if it's in the dashboard or if it's on a single page. For the deployment list, for example, when something extended, that handles, you know, I can't expand these collections here, but if I go into deployments, I can actually expand them. So that's the basic difference between expanded and not expanded version. Extended version. We can look at this component. This is where it becomes a bit more messy because it has a lot of information on it. We can see that the deployments are listed. This is just graphical information. We can see that inside of the collapsible. So if we go to deployments and let's close that, we'll click here. This is the collapsible. We can see that they actually have a pod list, and the pod list has a label selector property on it. So it says that you should only show data which is matching this set of labels from Kubernetes. And that's also extended, which means that you can actually delete or edit things, which you cannot do in the dashboard. That's the difference between extended and not extended. Let's go on to the pod list then and look at that one. Same thing here. It's a lot of complex, weird information that, you know, is related to the graphical part of this application. The drop down and things like that. You have the deletion job, which basically tells the pod service to go ahead and delete this pod in this namespace. And when you're done, you know, refresh. When we talk refresh in here in the actual components, we don't talk about refresh as in terms of fetching data from the backend. We talk about refresh as in redrawing the UI from the data that we already have. Because the refresh here, it goes to the pod and then lists, and then, you know, uses the list to fetch the information and format it on the screen. So it never actually does a data fetch here. That's done initially from the view, whoever wants to actually refresh it for real. As it's not something interesting to look at. So let's look at the backend then, how this backend is working. We can see that the main part of this application is basically just the main file here is to just, you know, sort of read the Kubernetes configuration, set up a Kubernetes client. That's what we do here. We set up a Kubernetes client. We set up a database. I use SQLite 3 here, but you could just as easily swap this for Postgres or MySQL or whatever database you want to use. It's just changing this one line of code, just changing your driver here, and then you're good to go to basically have everything connected to something else. I do use context very thoroughly here, so I make sure to close my context and my database very nicely when you do Control-C, for example, when you do an interrupt. We can look at, you know, if we want to start from the outer layer, we want to go to the server. You basically start a server. It requires a context so it knows when to quit. It needs a JVT JSON Web Token secret. It's what you input when you start your project in the terminal, and you have a Kubernetes client and a database, and that's basically starts all of this. When you do serve, it set up some routes, and these routes have, you know, different they're put in different packages for convenience. We have the upstream. It uses an authentication middleware. We can actually go into the authentication register first. It's going to authenticate, and then here's the register. Authenticate, yeah. Oh, this isn't the register. We don't have a register feature actually, but we have an authentication feature. The authentication feature basically just, you know, checks your password, set up your session with the appropriate permissions you should have depending on your role. It generates a JVT to you and passes this over with the scopes that you have, so you know, so that the front end knows what are my permissions. If anything fails along the line, we do a rollback, and we always use the request context here. So if you decide to shut down your browser in the middle of it, we will automatically roll back all of the things we have executed in your transaction. Now we can probably look at the authentication part of this. So we're going to core and then auth. Here we can see what happens when you do a request when you actually have a token and you pass it over. It checks your token, of course, and then it checks that you have access with your session, and it checks that the URL that you try to request matches a regex in your scopes, and that you have the appropriate read, add, edit, or remove permissions on them. So it matches your request to your scopes. So we can use the URL to determine if you are permitted to do what you want to do or not, which means that we can basically do fine-grained permissions without actually having to build a permission system around all that. We just look at your request and look at what you want to do with your request, and then see if you're actually authorized to do so. Moving on to look at some of these subcomponents, we can see that the deployments, for example, we have the routes where we set up the routes. We have the authentication middleware that ensures that these routes are not contacted as unauthenticated. We have, this is where the watching happens. So this is where you watch for changes with the Kubernetes client, and if there's a change, we basically notify all the subscribers of the deployment topic that a deployment has been changed. These are the upstream helper classes that you can use to, you know, tell the different users about different information. You can notify everyone, subscribers to a particular topic. You can notify a specific user or a specific session about some information. So the upstreams, the server keeps track of all the upstreams. It has a user session, and then it has a set of subscriptions, which is basically flags saying true or false if you're listening to this or not. Let's continue on the deployments and look at the delete action here. The delete action basically just says that, okay, we want to run a worker, we want to start a worker here, and I provide my username so that everybody knows who I am. And then I say the key for this is it's a deployment. There's a namespace and there's an ID. This is basically the fully qualified ID number of this item of which I want to delete. And then I give a function that takes a context, which is, you know, if you want to abort your worker, it takes a context, and then it says, you know, it returns some data or an error, and then it basically does some sort of work here. So that's basically how it works. That in here I define my work, and this rest is just the same for everyone. So this work is just skipped, and then we instantly get an information that the job has been started, and we return a job ID. There's a little sleep in here for 10 seconds. That's only for demo purposes, so you actually see a spinner. I said that earlier. we go into the run worker function, we can see that here it notifies everyone or the user that a job has been started, so that all your sessions can synchronize and get that information. This is the actual thread, if you want to call it that. This is your Go routine, which handles the actual job that you want to do. And yeah, basically you run the job, it returns an error or some data. If there's an error, that's a job failed. If it's not an error, that's a job completed, and then return the actual data that we want to know. And then we end with deleting the worker, so that's when we consider our job is fully finished. And that's the basics of the backend. There's no reason really to go through all of these, because they are basically, want to look at the pods, they're the same. They have a listener, they have a couple of routes, they have a delete, and they have list namespace and list. That's basically the same for everyone. It's basically the same for every type of component in Kubernetes. Well, what can we look at more? I told you about the workers. This is for fetching workers if you don't have any support for WebSockets. For creating admin user, just generate a random password. And this is for data definition, so setting up the tables the first time you start with an empty database. And yeah, that's basically it. If you have listened so far on this screencast and actually went through this technical part too, I want to congratulate you, and I want to thank you for listening. It's been very interesting telling you about this system, and hopefully this will I will continue to develop this in the future, and will be developed even further. Yeah, anyway, thanks for listening, and talk to you in the next one. Bye.